Okay, so last day we talked about that initial step into server-side development, and it's when you're talking about web development, as always. I mean, there's so many moving parts. Here's another aspect to that back end, and many more opportunities to make mistakes. So we're going to talk about relational databases. We'll talk about active record, which is what we call an relationship mapper, and we will use this new knowledge to organize our posts, our Finstagram posts. I'm going to use my cache model for the demo. Okay, so I who here's used a database like hands on, like even Mike? Yes, what one?
SQL.
SQL, yeah, I like any specific database management system, like what's that Microsoft one? I can never remember. It's not Access. Yeah, lots of different database management systems. Really, all we're doing is just finding a nice, fast way to retrieve and to save information and have it persist between executions. So, databases organized into tables, first of all. So you always, I like to think of them in terms of nouns or physical objects. This isn't always immediately true, but if you could think of a physical object in the environment, and you're writing some sort of application to that requires characteristics to be recorded, um, that object, the coffee cup, would be a table in your database. And inside of this database table, we have the properties that we want to collect. So if I'm using this weird coffee cup example, you might talk about the circumference. You might talk about thermal resistance. Does it keep your hand cool? You might talk about color, height, dimensions, all of these kind of things. These are the kind of things that we can collect and store inside of a database. Inside of that database, now we're going to have a whole bunch of different coffee cups. We got this one, we got a whole bunch at the back, and people have brought their own. Each one of those individual coffee cups is stored in a row. This is very similar, and I'm sure if you haven't used the database, you've probably used Microsoft Excel or something similar. Google spreadsheets are way better. If you do use this kind of stuff, use Google spreadsheets. But this is not unlike a database. Microsoft Excel is not a database. Sometimes people use it to organize their database or organize their data as though it was a database, but it's not. It's more like a very fancy calculator. So, but here you see this would be a post table. So you're working through your Finstagram, you should sort of see these properties or these column headers and say, okay, yeah, that's probably a post. We see our shark images and all this kind of stuff. Each new row in this database is a new post in your Finstagram application. So hockey web app, very primitive. I was having an interesting discussion with my dad last night. We we were getting a pirate stream of the Flames game, watching this thing on our TV. He was talking about how hockey has changed. We kind of arrived at this conclusion that it's because we're trying to use computers to compute better hockey, like we do in baseball, sabermetrics, right? Just calculating statistics, and that has probably changed the course or the way the game is played. If we were doing a very primitive version of that, and we wanted to model the entire league, we'd start about looking at these nouns, right? We'd talk about the team. Each team has a bunch of players. Each player scores a certain number of goals. I'm not sure if that would be a noun. I think in this context it is. And players play games, right? And teams play games. So you have all these different things out there in the universe, and they all have these relationships established between them. And it's up to you as the developer to tie those tables together. So, for example, like what columns or fields, if we're looking at this Microsoft Excel spreadsheet, how would you model a team, for example? What are some of the column names you'd put in that? I was thinking more like broad or like city. What city does he play in? Stadium. Team's going to have players, but you store players in a different table. Teams are going to play games. You store those games and the statistics collected in those games in a different table. All sorts of different ways to do it. You might even like break it down to logo, all this kind of stuff, right? You can collect. You're only limited by the space on your hard drive and your imagination. So Finstagram, by comparison, what are some of the obvious ones? I hate asking these obvious questions because no one ever responds. But you're familiar with your Finstagram application. What might be the very most obvious table in this database?
Images?
Certainly a table to contain the images. That would be a characteristic of one post. User, yes. So post and user. What else might we have? Comments. Yeah. Now you've seen your interface. There's one more. That would be a property stored in one of the tables. So we're just talking in general senses or general terms here. We have posts. A user creates a post. Users create comments. Likes, exactly. There's 4 likes. So we have 4 tables in our database, or at least you will by the end of probably the end of next Monday. So now when we talk about relationships, right? Because user created a post. Only one user created a post. But then on the flip side, any number of users can leave any number of comments. So somehow we've got to like take this single entry inside of the post table and then connect it to a user. And then connect the comments made against that post to a completely different table. Users, posts, likes, and comments. And we do the same thing for likes, of course. Any guesses as to how we do that? Hard question. When you're creating a database record, in every database, you're always assigned a unique ID. So if I have a post table, which might contain a few properties like immediate properties, like the image, the date and time was created, and all that kind of stuff, you would have a user ID column that just contains the ID associated with the user that made that post. For comments, yes?
Can you do some like access or something?
That's the one I was thinking of. Is it access?
Yeah.
That's a terrible one, but what can I say?
It's the same thing, right?
Yes, it is a database, and you can use SQL to perform queries on it. Yeah. But that's how we establish the relationship between these tables. Just unique identifiers. These all exist independently on their own. The relationships are established by recording the IDs of the objects to which they're connected. So this is what we're going to talk about. Well, this is kind of nuts and bolts stuff. This is more like this is more engineering stuff. But we have what's called an ORM, because when you get down to it, using SQL is kind of a pain. It's necessary to know, to have an appreciation for what's going on here. But what Ruby does, and what Ruby does, I think, probably better than most of the software I've used, is model database information like Ruby objects. So I can treat the information stored in my database the same way I would treat a hash or a string. Unless you've done it the other way, this isn't something you can immediately appreciate. But it's through this ORM that we connect our Finstagram application to the database. 2 separate pieces of software. The database is independent. We just deposit data inside of it, or delete data, or update data, and all the rest of it. So, keep going. I lost focus there for a second. And yeah, we use Active Record. This is definitely my personal favorite in terms of ORMs, and it just allows us to do these CRUD operations. Everything's got some cutesy acronym, right? Create, read, update, and delete. What else can you do with a database? Nothing. That's it. 4 operations. So if we want to create one, we create a model that maps onto a table. And you're going to see this hands-on as I do the demonstration. We're going to create a brand new model, create a database table, and we're going to connect the model to the database table. And it's going to be like the database isn't even there. It's just like you're running a Ruby program. In this case, to create, we simply pass it a hash of values, which you guys have already done. You've already done this manually. You're using that exact same technique, ultimately, to create new posts on your page. You're not going to have to type it in from this point on, but you'll have your users submit data, and it's all going to be modeled in a hash like this, and new users or new posts and new likes and comments are going to be stored in the database. So let's do that. Okay, so here's where we're at. This is where we left off last day. Everything's in good working order. We bridged that gap from just plain old HTML and CSS, and we started serving it up. Well, did I get the right one here? Yes, I do. Okay. Just to refresh our memories. So we modeled it the exact same way we're describing here. This data today is going to be stored inside the database. So let me just find my bearings here. I think I lost my notes. Give me a moment. I mislabeled it. Labeling and descriptive stuff is so very important. Just here and now. And I just need to make sure I remember where I'm at. Okay, so I think the first thing I want to do is create a database table. Now, in practical here and now terms, you're really only going to do this once, unless you want to recreate it because you made a mistake or something, which is okay. There's no problem with that. But at some point, you do have to tell the database the nature of the data that you're going to be sending or that you expect it to handle. So we do that through migrations. Migration file sets up individual tables in the database. For more advanced applications, it also allows you to change the structure of a database and retrace your steps, kind of like how Git works. So if you like a database in its previous state, you can always go back. That's what migrations allow you to do. So now I've just left a few handy notes here. I don't want users yet. I think that'll come on Monday. But I'm going to do I'm going to create a table for what I've been calling a cache, like a cache of junk that I want to come and raid later. So I've been calling them caches. I'm certainly open to suggestions. I'm not sure there might be a better name. So I'm telling my database, I want to create a table just to store each pile of junk that I find. And this is going to contain a few columns, and here's where I define them. So I don't want my username quite yet. I want a description. So for example, metal shelving or cabinets and scrap wood. Those are the examples we've been using. I also want the coordinates. And here you notice I'm just using a string data type. I'm not doing anything fancy here. Strings are probably, or they're definitely most appropriate here. Another thing that makes up a cache is the photo or the image. And then we had one more, and I think I'm kind of anticipating this changing. Actually, this is going to be an integer. This may change in days to come, but that days ago, just so that we can sort of measure how new this thing is and the likelihood of it still being there, not being picked over. The last one, this is kind of like a little bit of Ruby or I guess active record magic. Sets a couple of timestamps, just modeled from the date and the time that this cache was created and the last time it was updated. So there's going to be 2 extra columns here. And we've got this shorthand because this is just the natural thing to do. We want to know when a record was created. We want to know when someone changed it. That does that automatically for you. So tables defined is still not in the database. We have to tell the database we got to create a new one. Now we're using something called SQLite for development. And it is fine for development, but it is inappropriate if you're going to push this thing to Heroku, which is what we're eventually going to do. But what makes it kind of inappropriate is it's just an ordinary file. Databases use like some memory management that make retrieval and performing those CRUD operations a lot faster. So to actually tell the database, I need this table, I have to execute this migration. This is all part and parcel of the Ruby and Sinatra ecosystem, so you don't need to ask too many questions, you just got to remember what to do. And this will be relayed to you in the course or the lecture summary as well. So I say bundle exec rake db create. Now watch what happens when I do that. You saw me delete that db file up there. When I execute this, it's going to recreate that. It's going to be empty. So kind of the simplicity and the beauty of SQLite is also kind of its weakness. It's just data stored in a file, not exactly performant. The next thing we have to do, I'm just going to hit up arrow on my keyboard because most of this stuff is the same. I've got to run the migrations. I've got to execute the code that I've defined in this file here. So I say migrate. There we go. So now I'm going to show you, going to kind of replay this a little bit. When you're a developer, it's always a good idea to know how to use the command line. So if I want to actually see what's inside of my database and see what tables are defined, I can use this utility or this program. This is like the command line interface to the SQLite database. So I say SQLite db, I tell it the name of the file. For some reason, it never auto-completes for me. And I go in there and it says, okay, you're looking at the database. What do you want me to do? It's very helpful. If you're really curious, just run that help command, .help. It's going to give you an idea of what kind of operations you can perform. I just want to see the tables. So let's make a list of those. I've got 2. I've got these migrations, so it's kind of tracking the changes I've made to the database over time. Only done 1, so it's not really tracking much. But it also has this caches table. This is the one I just created when I ran that migration file. Start from the beginning. I'm going to drop that database. This is something you're probably going to do. You want to know how to start fresh. You're in development. You don't need to worry about user data or anything like that. There's going to become many times when you just want to start from a really sane spot that you know everything worked. So I say get rid of it. Call drop, and you'll notice the DB SQLite thing disappeared. I'm going to create it again. You can do this as many times as you want. Now, just to show you the change I actually made. So I'm going to go back to my SQLite command, and I want to see what kind of tables I have in here. Nothing. I don't even have the schema migrations. So I migrate. Okay, table created. Can go back into SQLite. See what tables I've got now. So I've got those schema tracking or the migration tracking. I've got my caches. So for those, yes.
Does it know what to migrate?
That's you tell it what to migrate. It knows because I told it to do all this stuff.
So, but it goes into, you have to have it over the DB migrate stuff folder, and then it will go get it.
That is how it's configured by default. Yes. Yes. A lot of this stuff, and that's why it's well, I guess it's less true of Sinatra, but Rails is what we call opinionated. It says, like, this is the best way to do it. If you want to deviate from this, you're going to be punished. Sinatra less so, but a lot of this stuff is default. A lot of its stuff's very sensible. You don't want to monkey with it too much.
And if you have multiple files or database scripts in that migrated folder, it won't. If you add, say, a new one,
That's a good question. That's a really good question. How does it know which one comes next? The easy answer is it's alphabetical. So now if I want to create a new table, and in fact, that's a good thing to demo on Monday. I'll create user tables. I'll create all that kind of stuff. I just need to make sure that when you do a directory listing, it comes next in line. And it'll never repeat that. It'll never repeat migrations it's already performed because that's all being tracked here. Just nice active record stuff. Ruby is a joy to work with. Okay, so, but for you actor people who have seen a little bit of SQL, this is where you give it the SQL statements. Say I want to see what's in my caches table, I would say select star, select everything from caches, show me what's in there. Nothing. I haven't created anything yet. We'll do a little bit more of this just to, to crystallize the concept, but then after that, Active Record is going to take care of the SQL for you. You don't need to do any of this stuff, which is, I hope is a good thing for you, because it's a good thing for me. So we've created a table. We've erased our table. We created a new table. Common developer operations. To get Active Record now to interface with the database, we need to create a model. And models by default go in here. And you probably have already seen your posts and your user table or your user models. But for each table in your database, there's going to be a corresponding model. Cache.rb. When we start talking in terms of Active Record, we lose the S. It's never plural. This is one of these opinionated, you adhere to this convention, otherwise you're going to suffer. You're going to bring more work upon yourself. The SQL table, it's plural, caches. Here on out, singular. Something to be aware of. Actually, a very important point to be aware of. So what we're going to do is just set up this cache model so that just because of the way things are set up and because Sinatra is so nice, we're going to be able to interface through the database with this special class called cache. And this stuff we're going to talk about in a future lecture, object-orientedness. I am inheriting from a broader class called Active Record Base. That's all we need. It doesn't look like there's a lot going on there, but there is. By declaring a cache model in this way, it inherits all the properties of this Active Record Base class. We'll do some object-oriented demonstrations in future lectures, but just be aware. Doesn't look like much, but there's a lot happening under the hood. So I think that step 2 is fixed. At this point, I can just go anywhere in my Ruby application and start making calls on the database. I think I'm going to do a little bit more manual stuff because that's what you're called to do in the coursework. So let's drop back down to here, and I'm going to introduce you to something called Tux. And Tux just named for, the Sinatra theme, Frank Sinatra, because he was a snappy dresser. This is a lot like IRB. The nice thing about Tux is that it loads all this default configuration so that now you can start talking to the database. You can't do that when you open up IRB. You can set it up to do it, but Tux does that all for you. So it's a nice thing to do. All right, so first thing I want to do, I'm going to take the long route. I'll say, give me a new cache with that capital C. So when I use that capital C, I'm talking about this class up here. That's the cache. And all I'm going to tell it right now is to give me a new empty object. Nothing's happening with the database just yet. If I do this, you're going to see the string representation put out to screen. You're going to see the description, which the column name in the table, coordinates, image, days ago, and you remember that timestamp method, created at and updated at. That all happened because I called timestamps right here in the migration. That's where those two column names came from. Right now, everything's empty. Nothing's been persisted to storage. So let's just start setting some of these things. Say cache. I'll just make some stuff up. Sorry, cache.description. What did I see the other day? I saw something really good. Now I can't remember what it was. Antique brass lamps. There we go. Okay, so now I just set a property inside of my active record cache object. I created this from the cache class defined here. This thing has all the properties of an active record object, which is why I can assign it using this method. So let's take a look at what's inside now. Before description was nil, oh, I said antique brass lamps. I meant antique brass lamps. Okay, well, let's move forward here. So let's say cache coordinates. I'm just going to make some up. I don't actually have any real ones handy. Like that. We'll say cache.image slash images slash lamps.jpg. So there's just test data. We're not actually going to see it. One last thing, cache dot days ago. We'll say, oh, I saw it 4 days ago. They're probably gone. Okay, so I look at my cache object now. All these fields have been set except for updated at and created at, and most important of all, ID. Never touch the ID. There's never an occasion that you guys are ever going to need to change or modify the ID. Never directly modify these either. The consequences are probably less dire, but now we're talking like, data fraud and forensics here. Just leave that stuff alone. Let Active Record take care of all that stuff and set these values for you. All the rest is fair game, and sometimes it's required. So we have this object, but we haven't done anything with it. I can call cache save, and this sends it off to the database. It was successful. It says true. And if you're really like into this SQL stuff, this is the SQL that Active Record generated for you. So it's still SQL, it's just you don't have to deal with it anymore, which is much nicer. Okay, so now just to show you that this is all actually working really well, I'm going to drop out of Tux, hit Control D. I'm going to go back into SQLite. I'm going to open up my database and start looking at poking around the tables. So I still have my caches table. This is the one I just created. Let's say I select star from caches, like that. So now I should get every single record. Only have one. Just created it in Tux. And there it is. There's my antique brass lamps, my coordinates, my images, and notice the things that changed here. Created at, last updated at, same date, naturally, just created it. And most important of all, this number 1, the ID. Now this is just an SQLite thing. We start counting at 1, we go up to however high the integers go in a 64-bit system. In more sophisticated databases, like what you're going to be using with Heroku, this is a pseudo-randomly generated hexadecimal digit. It's, again, not something you need to know about. Well, you need to know that it's there. You need to know that it exists and use it to establish relationships, but you never touch it. There's never a reason why you want to touch that thing. Okay, so now we've got one record in our database. Pretty good. You know what we should do, actually? Let's perform a different operation, and we'll start a little bit fresher. So let's go to Tux again and retrieve some of this data. I can call cache and use that cache object to find, like this. And there's all sorts of different methods that we can use to retrieve data. Maybe the best one to use right now. How does this work? Find by? Shoot, I've been using Node all day and now I can't remember. Let's see what find gives us. Oh, you know what? Let's just keep it simple for now. We're going to get into this on Monday. We'll say cache, give me the first object, like this. Whoops, cache. So this is the one I just created, test data. Antique brass lamps, yada, yada, yada. Here we go. I'm going to delete it. Cache, destroy. That's how we get rid of it. Remember CRUD. Create, read, update, and delete. So far we've created it. We've read it from the database. Now we're going to delete it.
And that just deletes one value.
That just should have deleted, yeah, the one value that I retrieved, what was previously stored in cache. And we can verify that. We'll go back into SQL. And we'll select star from caches. So if I was successful, this should just return nothing. Yeah, there we go. Could have done the update to correct the brash lamp, but there we go. All right, easy enough to do. Where are we now? Okay, so we've got an empty database. Let's create some real data. I'm just going to create one record, and I'm going to copy and paste because it's a little bit too onerous to type it all in. So I'm going to recreate this very first one up here, this press board. I'm going to put this into the database. So you saw me do this before. You saw me do cache equals cache.new. We can skip all this stuff and just give it the data all at once and create it all in one go. So I'm going to use the create method to do that and paste all that data I just copied. Close it off, hit enter, and there we go. So cache, I know it was successful because now I have an ID and I have an updated at and created at field in my database table. Unless it's saved, you're not going to have an ID. And unless you set timestamps, you're not going to have this stuff either. But the ID is key. And notice that it incremented. I started off at 1. Now I'm at 2, and it's just going to keep going up and up and up. It doesn't matter. Because you guys are definitely going to make mistakes, and you're going to want to go back, and you're going to want to edit your data. It makes no difference. Ignore the ID. Know that it's there. Just don't touch it. All right. So now I've got one item in my database. Now it's time to actually use Sinatra to retrieve this information. I come to my actions RB, and I'm going to comment all this stuff out just to prove to you that nothing's happening here.
How do you comment?
Well, I'm using something called Vim, the Vim emulator. I think that there is a way to do it. The way I do it is I hit Control V, highlight the stuff, hit uppercase I, and do that, right? You're not doing it that way. Mine's, yeah, this is, I don't know, is that old school? I'm not even sure. I don't think it is. I learned how to use Vim at iStock Photo. And the only reason I learned it there is because I wanted to fit in, because everybody used Vim. So I learned it, and it turned out to be a huge productivity enhancement. So I'm sure there's a way to do that on Cloud9, but I don't know how to do it apart from Vim. There you go. Okay. So I want to kind of reinforce this fact that we're no longer setting this data manually. I'm going to just give myself an empty array for now to make sure everything's running correctly. If it is, I shouldn't have any of this stuff. This stuff should all disappear. Yeah, there it is. I got this white space at the bottom. Can't scroll up and down. I've just got an empty array of caches. I know I've got one written to the database because I just created it. And I can use this handy method. Whoops. Using that cache object I can just retrieve every single database or every single item in that cache table. So if I did this correctly, I should see one record. And there it is, abandoned press board. Okay, so let's get back to where, no. Let's leave that for now, and I'm going to show you one more trick, and then I'm going to let you go out and do your work. As I kind of stressed at the beginning, you're going to find many occasions that you just want to reset and start your database over. You don't want to have to do this every single time in Tux. You just want to run a script and populate it with some test data like what I've done here. And of course, the test data that I'm going to use is the one that we defined early on in the class. So I'm going to use what's called a seed file. And I'm going to create all of my records in this seed file. Anytime I need to reset my database, I just execute seeds. Okay, so got to refer to my notes here. So pretty simple stuff. It's nothing fancy. I'm going to create an array with all the data that I want to find. It's an empty array. I'm given a little bit of space here because I'm going to copy and paste. So I come to actions, and with a little bit of doctoring, I can recycle all this data that I already took the time to type. So I've got to clean it up a little bit, get rid of these variable assignments. Like that. I've got to separate each individual hash with commas. Like that. Get rid of all that stuff, and then all the way down here at the bottom, now we're good to go. All I got, simple array filled with sample data. That's all I'm going to do. So now I come down to here. This should all be kind of review for you. I use that each function because I want to do this for each item in my array. Sorry, each method, I should say. And it's really easy because each of these items is a hash, and that's exactly what active record takes to create a new record in a table. So I call that big C cache class. I say create, and I want to create one at a time, every single one of those items in the database. All right, so let's see what happens. Let's see if I can actually get this thing to run. There's going to be an error, and we're going to have this opportunity to reset the database. But, well, it's not a critical error. It's just a content error. So I'm using that same bundle exec command. I say bundle exec db, or sorry, rake db seed, just like that. It's all set up for you. This is so many of the nice things about Sinatra. I execute that. You're going to see a whole bunch of SQL fly by on the screen. And if I did that correctly, and if everything else falls into place, I should actually see 2 entries for abandoned press board, and then the other 2 entries for the shelves and the cabinets. So refresh, hits the actions.rb file, retrieves all that information from the database. There's 1 abandoned press board, 2 abandoned press boards, metal shelving and pipes, yada, yada, yada. We can do that a whole bunch of times. Probably wouldn't want to do this because you want original data, but okay, so I'm making a real mess of my database. Got a whole bunch of duplicate entries. I don't even know how many times I did that. Let's try it. So that's, whoop, what happened? No internet connection. What is that? Oh, there we go. It's getting all that stuff. Okay, so yeah, really the only difference, I mean, this little scroll bar became a lot shorter when I made all those records. So it goes all the way down the page. There's a whole bunch of stuff in there. This is no good. Let's fix this. Bundle exec rake db drop. Get rid of the database. It's all gone. Remove the SQLite file. If I run it this time, it's not even going to find it. This is going to crash hard. Watch. No such table. Okay, let's fix that problem. Create. Starts me off with a blank database file for SQLite. Migrate. Okay, so now it's not going to crash. I just don't have any content. But I got to start fresh, right? Made some big mistakes. Nothing there. Okay, one last step. Seed. Voila. You are now a proficient developer because you made these mundane tasks, well, semi-automated, and you're doing as little work as possible. There you go. 3 of those. You can start fresh anytime you want. So one last thing I want to do, just to remind you, so I've got my Git page here. I got to make sure I got my Git remote correctly set. Week 3, day 2 demo. Okay, so I'm going to commit everything. Git commit minus AM. That means just, oh, wait, hang on. Git status. So I've got some changed files here. That's a little dim. It's kind of hard to see, but these were some pre-existing files that were modified. And I've got some files down here that Git's never seen before. Now, I don't want this DB SQLite, so I'm just going to add these things one at a time. I'll say git add app. That'll just add everything inside of that app directory. I'll say git DB. We probably don't need the schema. Yeah, let's get the schema anyway. DB schema. I just want to skip over that database because you don't really want to like store a database file to GitHub. It's just don't do it, right? You want to create data and have it always, living and fresh. So I do this, hit enter. Whoops, I said git add DB schema. There we are. Okay, so I'm just going to ignore this one for now. There's a way to ignore that automatically. Maybe we'll talk about that another time. I'm just going to commit everything at once. Git commit minus AM. Get database set up for week 3, day 2. I don't know. I could probably come up with something better than that, but that's what we're going to use. Hit enter. Git push. And it's off. Saved in the cloud. You can relax. All right. Any questions? It's a lot of stuff, and it only gets harder and harder and harder. You guys saw the easy stuff. Yes, question.
I use cache and add cache.
Excellent question. This is all part of the object-oriented paradigm. When you're talking about object-orientedness, you're always talking about classes. Classes are like the blueprint. It's like how everybody lives in a house, and there's that class of dwelling, but not everybody lives in the same house. The cache class is like that blueprint. The individual houses on the street are the objects created from that class. So it's just like, you take that blueprint and you just make as many houses as you want. When you're talking about classes, the name is always uppercase. This is abstract. It's non-concrete. The object is concrete. It's like the physical house on the street. Big C for class, little c for objects. Good question. Any other questions? All right. You guys will have fun with Active Record today.